the ocean has always guarded secrets beyond explanation. For thousands of years, sailors told stories that no one believed, gigantic walls of water appearing from nowhere in the darkness of night. Viking sailors, Mediterranean traders, and Japanese fishermen all described waves higher than 30 meters. But no one recorded them with hard measurements. And because of that, no one believed them. Throughout the 19th and early 20th centuries, physics described ocean waves with simple linear equations. Under that theory, a 30-meter wave was nearly impossible. Science chose mathematics over the testimony of sailors. Survivors of giant waves were often dismissed as confused or exaggerating. Their testimony was rejected even when ships were completely destroyed. The sea never needed to prove what it had done. In the 20th century alone, hundreds of large ships vanished without a trace along major sea routes. No distress signal, no significant wreckage. Reports simply stated, "Cause unknown." To understand why this is terrifying, imagine this. Ordinary storm waves are around 4 to 6 meters high. A rogue wave can be 5 times taller, equal to a 10-story building, and it appears within seconds. Even in the largest storms, modern ships can handle waves up to a certain limit. But rogue waves do not always come with storms. They can appear in moderate seas, without warning and without clear reason. For centuries, maps of mysterious ship disappearances formed a strange pattern, clustering in certain regions of the world. But science had no answer, until one day in late 1995. January 1st, 1995, the Draupner oil platform stood in the North Sea. Automatic sensors recorded wave data continuously, just like any normal day. No one knew that night would change scientific history. At 3 p.m., the sensors recorded something extraordinary. While surrounding waves were only 11 to 12 meters high, one solitary wave reached 25.6 meters. More than twice as large, exactly as sailors had long described. When the data was analyzed, the scientific community was stunned. For the first time in history, a rogue wave had been captured by scientific instruments. Impossible to doubt, impossible to deny. The Draupner Wave, as it became known, marked a historic turning point. Within a few years, dozens of studies were published. The door to an entirely new scientific field had opened. To put it in perspective, the largest container ships in the world may rise about 70 meters from the waterline. But the section directly exposed to waves, the hull above sea level, is only around 15 to 20 meters high. A Draupner-sized wave could engulf many modern ships. In 2003, the European Space Agency used radar satellites to scan the oceans. In just 3 weeks, they detected 10 rogue waves around the world. They were not as rare as anyone believed. Under older probability models, a wave like Draupner should appear only once every 10,000 years. But satellite data showed they were happening somewhere on the ocean almost every week. The old theory was completely wrong. Researchers began reopening old records. Many shipwrecks once blamed on unusually bad weather now had a more convincing explanation. Rogue waves had been killing people for centuries before science admitted they existed. What makes rogue waves especially dangerous is not only their height. Their front face can become nearly vertical, more like a wall of water than a normal wave. There is nothing for a ship to climb or ride over. Measurements show that rogue waves can exert around 100 tons of pressure per square meter. By comparison, ordinary structural steel may withstand only 25 to 30 tons per square meter. A rogue wave can bend and tear open a steel hull like paper. On the cruise liner Queen Elizabeth II, a giant wave bent thick steel plates and shattered bridge windows 22 meters above the waterline. The captain later described it as climbing a cliff. The danger does not come only from the crest. Ahead of many rogue waves is a deep trough, often called the Hole of Death. A ship is dragged bow first downward, just as the wall of water crashes down from above. In 1978, the cargo ship MS München, one of the most advanced and safest ships of its time, vanished completely in the Atlantic Ocean. 28 sailors were lost. The only recovered lifeboat had twisted mounting hooks, evidence of an impact force estimated in the tens of tons. At least 22 supercarriers were lost between 1969 and 1994, before science proved rogue waves existed. Today, many researchers believe a large share of those sinkings were linked to this phenomenon. The true number may be far higher. An important distinction: rogue waves are not tsunamis. Tsunamis are generated by earthquakes and travel thousands of kilometers. Rogue waves form locally and suddenly, with no conventional warning system able to detect them early enough. How can a gigantic wave appear from nowhere? Science proposes several different mechanisms. The first and most intuitive is wave reinforcement, when many waves from different directions meet at the right place at the right time. When the crests of two waves align, they reinforce each other and create a taller wave. Across the vast ocean, dozens of waves from different storms can converge at one point. The result is a single wave carrying the combined energy of them all. The second theory involves ocean currents. The Agulhas current near southern Africa flows against large swells arriving from the Indian Ocean. When waves meet an opposing current, their energy is compressed and wave height can rise suddenly. This mechanism helps explain why waters off South Africa are among the most dangerous on Earth for shipping. Large swells from the southern Atlantic meet the Agulhas current, and sometimes an abnormal wave is born. The third theory, and the most complex, is nonlinear interaction. Under certain conditions, waves do not simply add like normal arithmetic. Energy leaks from smaller waves into larger ones, creating an avalanche effect. In laboratories, scientists have successfully recreated this phenomenon in scaled wave tanks. When tuned to the right frequencies, small waves suddenly collapse into one giant solitary wave, just like what happens in the real ocean. More frightening still, rogue waves are not caused by only one mechanism. All three processes can happen simultaneously at the same point. When they do, a wave can rise almost instantly with more energy than any ship was designed to withstand. Modern computer simulations show that rogue waves do not last long. They form within seconds, reach a peak, then collapse again in under a minute. But that is enough time to destroy anything in their path. Statistical analysis shows that real ocean wave height distributions have fat tails, meaning extreme events happen far more often than standard Gaussian models predict. This is why the old theory failed completely. Although rogue waves can appear in any ocean, some regions are recorded far more often than others. These are places where strong currents, heavy winds, and seafloor topography combine to create ideal conditions for the phenomenon. Waters off the east coast of South Africa are among the most dangerous on Earth. The Agulhas current races southward against giant swells arriving from the 40 to 50 degrees southern latitudes, a zone sailors call the Roaring Forties. The Gulf Stream in the North Atlantic is another hotspot. When giant winter waves from the north meet the warm opposing current, the probability of rogue waves rises sharply. It is also the busiest shipping route linking Europe and North America. The North Atlantic in winter is one of the harshest seas in the world. Successive low-pressure systems make 8 to 12-meter waves normal conditions. In that environment, a rogue wave can hide among seas that are already enormous. Seafloor topography also influences rogue wave formation. Where ocean depth changes suddenly, wave energy can be focused much like light through a lens. Regions with deep trenches beside continental shelves are especially dangerous. The North Sea, where the Draupner platform recorded historic evidence, is also on the danger list. It contains hundreds of oil platforms, and many mysterious structural damage incidents are now being reconsidered in a new light. A new concern is emerging. Climate change is altering global wind patterns and ocean currents. Some researchers warn this could increase rogue wave frequency in regions once considered less dangerous. The most important question today is no longer whether rogue waves exist, that has already been proven. The question is, can we predict them in advance? And if so, how much warning time is needed to save lives? Today, NOAA and equivalent agencies in Europe operate thousands of wave monitoring buoys across the oceans. Data from these buoys is transmitted continuously, providing a real-time global picture of sea conditions. Artificial intelligence is being brought into this battle. Machine learning models are trained on millions of historical wave data points, searching for precursor patterns that may appear before a rogue wave forms. But this remains an extremely difficult challenge. Early results suggest warning signals may be detected 2 to 4 minutes before a rogue wave fully forms. With modern communication systems, that could be enough time for a crew to carry out basic protective measures. Modern radar satellites can scan vast ocean areas in only minutes. Combined with surface buoys and AI models, a global early warning system is slowly taking shape, though it may still take years to fully mature. Alongside forecasting, shipbuilding is evolving as well. Some new ship designs include reinforced bows and strengthened vulnerable sections, applying what we have learned about the true force of rogue waves. Today's young scientists grew up in a world that already accepts rogue waves as reality. They no longer need to convince others the phenomenon exists. They can focus directly on one question: how do we protect people from it? The chance of one specific ship encountering a rogue wave on a single voyage is very low. The ocean is vast, and although these waves are more common than once believed, they remain extreme outliers on a broad spectrum. But when small probability meets massive scale, the consequences can be catastrophic. The story of rogue waves is a lesson in intellectual humility. For centuries, we denied what those who lived at sea understood through direct experience. Sometimes the best evidence is not an equation, but survival itself. The ocean covers more than 70% of Earth and still holds countless mysteries. Rogue waves remind us that nature is always more complex than our models. Each time we think we fully understand it, the ocean finds a way to prove otherwise. Rogue waves appear suddenly, violently, then vanish as if they never existed. They are among the most terrifying and mysterious phenomena nature has created. And somewhere out there, right now, in the darkness of the deep ocean, a wave like that may already be forming. The ocean covers more than 70% of the Earth. Here, there are no rules, only the strong and the weak, predator and prey. Every species has found its own way to survive. Beneath the surface lies a completely different world. Here, life and death are separated by just a second. Speed, intelligence, and coordination determine everything. Today, we will witness 6 species and 6 different survival strategies. None are perfect, yet each has endured through millions of years of evolution. Flying fish are among the strangest creatures in the ocean. They possess wide pectoral fins and an incredibly powerful tail, 2 survival tools refined over millions of years of evolution. When danger strikes, flying fish do not hide. They escape their predator's dimension. With powerful tail beats reaching speeds of 70 kilometers per hour, they launch into the air. In the air, they can glide over 200 meters using wind and momentum alone. In this moment, they are truly free, beyond the reach of predators below. But freedom comes at a cost. Above, seabirds patrol the skies. The flying fish escapes one danger below, only to enter another above. And the moment they touch the water, the Dorado is already waiting. A clever predator that has learned the pattern. Flying fish must land. The only question is where and when. The strategy of flying fish is simple yet bold, using speed and 3-dimensional space to escape. They cannot hide, they cannot fight, they can only fly. And sometimes, flying far is enough to survive. Sardines have no great speed, no sharp weapons, no armor. The only thing they have is each other. And they have turned that weakness into a strategy. The bait ball is one of the most complex defensive structures in the ocean. Each fish swims tightly beside the next, reflecting light and creating the illusion of a massive, chaotic organism. To predators, the shoal creates visual confusion. Millions of flashing reflections overwhelm the brain, making it nearly impossible to target a single fish. Inside the sphere, there is a harsh order. The weaker fish push toward the center, the safest place, while the stronger ones are forced outward, becoming a living shield for the group. But when multiple predators attack at once, the strategy collapses. The shoal is compressed from all sides, space shrinks, and the defensive sphere becomes a deadly trap. Strength in numbers only works while the group holds together. Once it breaks, what was once a shield becomes a perfectly packaged feast for predators. Dolphins do not hunt with strength, they hunt with intelligence. They are among the few ocean predators with strategies rivaling those of primates on land. They assign roles with precision. One group forms the outer line to block escape, while another drives the shoal toward the shore. No commands are spoken. They communicate through sound and body signals. Wave-making is the peak of this strategy. Moving in perfect sync, dolphins generate currents that force prey into shallow water, where there is no room to escape. Strand feeding, hunting by surging onto land, is one of the rarest and most dangerous techniques. The entire group rushes ashore on one side, cutting off every escape route. The risk is extreme. A delay of just seconds can leave a dolphin stranded. Over time, sand wears down their teeth, the long-term cost of a strategy that demands perfect precision. But when it works, the efficiency is nearly perfect. This is not luck. It is the result of thousands of hours of learning, observation, and knowledge passed down through generations. When the feeding frenzy begins, tuna strike from below, birds dive from above, and sharks circle all around. That is when the latecomer arrives. And this hunter needs no complex strategy. A bride's whale can weigh up to 20 tons and reach 15 meters in length. It does not need speed or coordination. Size and gravity are the only weapons it needs. With its mouth wide open, the massive body surges straight through the shoal. In seconds, tons of fish disappear. No refined technique, just raw power applied at the perfect moment. Baleen plates trap the fish while expelling water. A single lunge can yield hundreds of kilograms of food, equal to days of hunting for other predators. After the strike, the remaining fish are still hunted by others. The whale takes the largest share, then disappears. The bride's whale is the finisher, arriving after the prey has been cornered, taking the biggest reward with the least effort. This is the strategy of ultimate power. This is one of the most extraordinary spectacles in nature. Completely different species hunting together without language, without agreement. Tuna strike from below. They are the speed machines of the ocean, reaching up to 70 kilometers per hour perfectly built to tear through prey formations. Copper sharks circle from all sides, preventing the shoal from expanding. They do not rush, they wait, observe, and strike at the perfect moment with minimal effort. Seabirds attack from above. Their dive speed and force allow them to precisely target fish exposed at the surface. The most remarkable part is this: they do not attack one another. There is no communication, yet each species seems to understand its role and boundaries. Pressure from above, below, and all around leaves the shoal with no escape. This is a perfectly evolved hunting system shaped over millions of years. They take turns attacking, no chaos, no conflict. This level of efficiency is not learned. It is deeply embedded in instinct through evolution. When the tide retreats, a new world emerges. Isolated pools, stranded crabs, and trapped fish become a paradise for a creature that can walk. The octopus is a master of camouflage. Its skin can change color and texture in less than a second, turning it into whatever surrounds it. On land, its 8 arms become 8 legs, each lined with hundreds of suckers, not just for grip, but for sensing temperature, taste, and texture. Air is its weakness. Its skin must stay moist to breathe, so it moves quickly, never lingering on dry ground, always choosing the shortest path between pools. In the new pool, its arms spread like a sensory network. The crab has no chance. The octopus strikes from the one angle it cannot defend. The octopus does not need the vast ocean. It extends its hunting grounds onto land, where almost no rivals exist. Adaptability is its ultimate weapon. While others are limited by their environment, the octopus simply overcomes those limits, a very different and highly effective evolutionary strategy. Flying fish choose a third path, neither fully in water nor entirely in air. They live in the space between two worlds, and that space is their survival. Sardines show that weakness can become strength when organized. Alone, they cannot survive, but together, millions form an almost impenetrable entity. Dolphins prove that intelligence is not exclusive to humans. Planning, role assignment, and learning from experience all exist beneath the ocean's surface. The bride's wail reminds us that sometimes the best strategy is patience and timing. You do not need to be first. Sometimes the last to arrive holds the greatest advantage. The multi-species hunting system is the purest example of cooperation without language. No one leads, no one commands, yet it operates with near-perfect precision. The octopus is the ultimate example of adaptability. In a world where most species specialize in one environment, it chooses to master them all. From a distance, the ocean appears calm. But beneath the surface, every second is a battle, a strategy, a lesson in survival shaped over millions of years. Three core strategies: intelligent escape, collective defense, and coordinated attack. Each species follows a different path, and each path leads to survival in its own way. The ocean has no audience, only creatures fighting every day to survive. And in this struggle, there is no perfect strategy, only one that is good enough to live another day. From space, Earth holds a secret at its southern edge. A white, frozen, silent continent larger than Europe. A place where nature writes its own rules. Antarctica, the coldest, windiest, and most isolated continent on Earth. A land that belongs to no nation, no one, only to time and to ice. Here, the sun does not rise or set in the usual sense. In summer, it circles the horizon endlessly, day and night. A golden light that never fades, surreal and desolate. More than 98% of Antarctica is covered by ice, averaging 2.3 kilometers thick. Beneath it lies a real continent, with mountains, valleys, and lakes, all buried for millions of years. In this absolute wilderness, life still finds a way. The emperor penguin, a symbol of endurance and will. It does not escape the cold. It chooses to live within it. In 1983, temperatures at Vostok station dropped to minus 89.2 degrees Celsius, the lowest ever recorded on Earth. At such extremes, the air can freeze human lungs within seconds. Even breath turns to ice before it touches the ground. Adiabatic winds, the most violent winds on Earth, can reach 320 kilometers per hour. They form as cold air rushes down from the ice plateau toward the coast. A single storm can bury an entire research station within hours. A whiteout, when sky and ground merge into a single field of white. Humans lose all sense of direction, unable to tell up from down. Many explorers have died just meters from their camps. Beneath the smooth snow lie crevasses hundreds of meters deep, hidden like invisible traps, waiting for the smallest mistake. One wrong step can be the last. In winter, Antarctica is plunged into darkness for 6 months. Temperatures drop further, winds intensify, and no rescue flights can reach it. Those who remain must face both the cold and complete isolation. Yet within the darkness comes something extraordinary. The aurora australis dances across an untouched sky. A cosmic display of light reserved for those brave enough to stay. Here, humans are not masters, they are only visitors. Every day is a test of body, mind, and will. Antarctica shows no mercy to carelessness, yet rewards those who respect it. The Southern Ocean encircles Antarctica like a vast natural moat. Here, the Pacific, Atlantic, and Indian Oceans converge. Waves rise up to 15 meters high, with no land to break the wind for thousands of kilometers. The Southern Ocean is the engine of global ocean circulation. Dense cold water sinks here, driving warm currents across the planet. If this system were to stop, Earth's climate would be transformed entirely. The Southern Ocean is the richest feeding ground for humpback whales. They migrate thousands of kilometers just to reach these waters each summer. Their songs travel for hundreds of kilometers underwater, a mysterious language of the sea. Krill, tiny creatures only a few centimeters long, form the backbone of the Antarctic ecosystem. A blue whale can consume up to 4 tons of krill each day. If krill disappear, the entire food chain collapses. Emperor penguins can dive deeper than 500 meters and hold their breath for over 22 minutes. Their bodies slow their heart rate to conserve oxygen. Beneath the surface, they become perfect hunters. Weddell seals are the southernmost living mammals on Earth. They carve breathing holes through ice to access the ocean in winter. Their calls echo beneath the ice like strange, otherworldly music. Icebergs are more than frozen water. They carry minerals and nutrients from land into the sea. As they melt, they feed algae, the foundation of the ocean's food web. The Southern Ocean generates the most powerful storms on Earth. With no land to block the winds, they circle the continent endlessly. Sailors named these waters the Roaring Forties, furious 50s, and screaming 60s. Calving, the moment when a massive block of ice breaks from a glacier and crashes into the sea. A single event can trigger waves like a small tsunami and thunderous echoes. This is how giant icebergs are born. The Lambert Glacier, the largest in the world, stretches over 400 kilometers wide and 700 kilometers long. It moves only meters per day, almost invisible to the eye. Yet its force can crush mountains and reshape the land itself. Each centimeter of ice core is a page in Earth's climate history. Tiny air bubbles inside hold ancient atmospheres. By studying them, scientists can read temperatures and air composition from 800,000 years ago. Ice core data reveals that today's CO2 levels exceed anything seen in 800,000 years. Ice does not lie, it only records truth. And that truth is warning us about what lies ahead. The Transantarctic Mountains stretch over 3,500 kilometers, one of the longest ranges on Earth. Yet most of it remains buried beneath ice, with only the highest peaks exposed. It forms a natural divide across the continent. Nunataks, peaks rising above the ice, are the loneliest rock islands on Earth. Only lichens and moss survive here. They stand as witnesses to millions of years of buried history. Using ice-penetrating radar and seismic waves, humans have mapped what lies beneath. Mountains higher than the Alps, valleys deeper than the Grand Canyon. A hidden continent sleeps beneath the ice. In 2000, iceberg B-15 broke from the Ross Ice Shelf, spanning 11,000 square kilometers, larger than Jamaica. It drifted for years before breaking apart. A single event like this can alter ocean currents and regional weather. Russia's Vostok station sits at the heart of Antarctica, on an ice plateau 3,500 meters high. It is the coldest place ever recorded on Earth. And beneath it, buried under 4 kilometers of ice, lies one of science's greatest mysteries. Lake Vostok, stretching 250 kilometers long and 50 kilometers wide, is one of the largest lakes on Earth. Yet it has remained sealed beneath 4 kilometers of ice for over 15 million years. No light, no atmosphere, only water, pressure, and darkness. The water temperature is around -3 degrees Celsius, yet it does not freeze. Immense pressure from the ice above keeps it liquid. Geothermal heat from below sustains this extraordinary environment. In 2012, scientists drilled through the ice and reached the lake for the first time. In the samples, they found traces of microbial life, living in total darkness. These organisms have been isolated since before humans existed. Lake Vostok has become a model for studying life beyond Earth. Europa, a moon of Jupiter, may hold a similar ocean beneath its ice. If life can exist here, it may exist there and far beyond. The greatest challenge is not drilling through 4 kilometers of ice. It is reaching the lake without contaminating it with surface microbes. If we fail, we may lose the truth forever. Lake Vostok still holds most of its secrets. We know it exists and that it may harbor life. But the true answers remain hidden in darkness, beneath 4 kilometers of ice. The Antarctic Peninsula is warming 3 times faster than the global average. Glaciers that have existed for thousands of years are retreating at unprecedented rates. Antarctica is changing, and that change will affect the entire planet. If all Antarctic ice were to melt, global sea levels would rise by 58 meters. Hundreds of coastal cities would disappear beneath the ocean. This is not science fiction, it is basic physics. Thwaites Glacier, known as the Doomsday Glacier, is losing mass at an alarming rate. If it collapses, global sea levels could rise by 60 centimeters. Its failure could trigger the collapse of even larger ice systems. Emperor penguins depend on stable sea ice to breed. When ice forms later and melts earlier, chicks cannot survive long enough to mature. In 2022, one colony recorded a 100% chick mortality rate due to ice loss. In 1959, the Antarctic Treaty declared the continent a place for peace and science. No nation may claim ownership. It remains the only fragile shield protecting Antarctica from division. More than 70 nations are present in Antarctica for science. Here, even rival nations collaborate and share data. It is one of the few places where science stands above politics. Every day, terabytes of data are sent from Antarctica to the world. Temperature, ice thickness, atmospheric data, marine life. Antarctica is Earth's early warning system, and it is sending signals. From above, drifting icebergs resemble fragments of another world. Each carries a story from the continent into the ocean. And those journeys are growing shorter as the ice melts faster than ever before. In Antarctica's summer, the sun never sets. It circles the horizon, casting an endless light. An experience that reshapes how we understand time and space. The submerged part of an iceberg is even more surreal than what lies above. Light filters through it, creating colors beyond description. A hidden world melting away before most will ever see it. Not all of Antarctica is silent. Adelie penguin colonies are loud and alive, like crowded cities. Life here is not fragile, it is fierce and resilient. Sometimes nature creates masterpieces without an artist. A perfect ice arch reflected in still water. No words are needed, only the understanding that this place must be protected. Aurora and ice share a single moment. One changes every second, the other has endured for millions of years. Yet both are now changing in ways we do not fully understand. Antarctica is not silent. It speaks through cracking ice, howling winds, and restless seas. It speaks through data and traces of life. The question is, are we listening? Antarctica reminds us that there are still places beyond human control, but not beyond human impact. We cannot own it, yet we can destroy it, and that is exactly why we must choose not to. Over 70% of Earth is covered by oceans. Yet global trade and energy flows depend on a few incredibly small points. These are strategic straits, where history, geography, and power converge. Every day, thousands of ships carrying oil, gas, food, and goods pass through these narrow corridors. Even a small disruption can shock the global economy. These are known as strategic choke points. Among hundreds of straits worldwide, 5 stand out: Hormuz, Malacca, Gibraltar, Bosphorus, and Bering. Each has unique natural conditions that shape its value and risks. Our journey will take you through each strait, exploring their natural conditions, trade importance, and geopolitical roles. Let's begin with the most volatile strait on Earth. From space, the Strait of Hormuz appears as a narrow passage connecting the Persian Gulf to the Arabian Sea. At just 34 kilometers wide at its narrowest point, it is the world's most critical energy artery. Every year, billions of dollars worth of oil flow through it. What many don't realize is that the seabed of Hormuz is relatively shallow, averaging less than 60 meters. This makes it highly vulnerable to blockades using mines or submarines. Militarily, its shallow depth is a key control factor. The surrounding terrain of Hormuz is dominated by deserts and rugged mountains, especially on the Iranian side. These provide ideal positions for missile systems and surveillance. Nature itself has granted Iran a significant strategic advantage. Every day, around 21 million barrels of oil pass through Hormuz, nearly one-third of global supply. Warm waters and relatively calm seas favor navigation, but the extremely dense traffic means any incident can have serious consequences. No other strait on Earth concentrates as much oil flow as Hormuz. It supplies energy to much of Asia, Europe, and the United States. If Hormuz were closed for just 1 week, global oil prices would surge immediately. This region is a constant flashpoint between Iran and the United States. Tehran has repeatedly threatened to close the strait in response to sanctions. Washington maintains a naval presence here to ensure freedom of navigation. All Gulf nations, including Saudi Arabia, the UAE, Iraq, and Kuwait, rely heavily on Hormuz to export oil. There are no strong alternatives, which is why the strait is protected at the highest international level. History has shown that whenever tensions rise in Hormuz, global oil prices surge instantly. In 2019, tanker attacks sent shockwaves through global markets within hours. Iran has heavily invested in small submarines, fast attack boats, and coastal missile systems, all designed to dominate Hormuz's narrow and shallow waters. This asymmetric power forces even major powers to think twice. Hormuz stands as the clearest symbol of the world's dependence on tiny geographic, just 34 kilometers wide, yet capable of shaping the fate of the global economy. This is where nature and geopolitics converge at their peak. If Hormuz is the artery of oil, then Malacca is the bridge between two great oceans. Stretching over 800 kilometers, it connects the Indian Ocean to the Pacific, running between the Malay Peninsula and Indonesia's Sumatra Island. Malacca is the second busiest shipping lane in the world, after the English Channel. Over 80,000 ships pass through each year, carrying around 30% of global trade. A humid tropical atmosphere blankets this busy route year-round. Unlike Hormuz, Malacca is shallow and winding in many sections. Its shallowest point is around 25 meters, limiting ship size. Ultra-large tankers are forced to reroute through Lombok or Sunda, adding days to their journey. Tropical weather creates major navigation challenges. Dense fog, heavy rains, and complex currents between islands often reduce visibility. Local pilots are essential for guiding large vessels safely. China, Japan, and South Korea rely heavily on Malacca for energy imports from the Middle East. This is why Beijing calls it the Malacca Dilemma, one of its greatest strategic concerns. Malacca has a long history of piracy. Small, fast boats can hide among countless islands before launching sudden attacks. Joint patrols by Malaysia, Indonesia, and Singapore have significantly reduced these incidents in recent years. Singapore, small yet incredibly wealthy, has built its prosperity on its position at the gateway of Malacca. This port is one of the busiest and most efficient in the world, handling billions of dollars in goods annually. At its narrowest point near Singapore, the two shores are less than 3 kilometers apart. Small fishing boats and massive container ships share the same narrow waters. The traffic management system here is as precise as air traffic control. China has invested billions in alternative routes, including pipelines through Myanmar and ports in Pakistan and Sri Lanka, all to reduce reliance on Malacca. This shows how a single strait can shape the strategy of a global power. Malacca is more than just a strait, it is Asia's lifeline. Trade, energy, and power for much of the continent flow through these waters. It is no surprise that every major power seeks influence here. Mount Gibraltar, a limestone massif overlooking the sea, was once called by the ancient Greeks one of the two pillars of Hercules, the boundary between the known world and the boundless ocean. Today, it remains just as strategically important. Gibraltar is where two very different seas meet. The Atlantic Ocean and the Mediterranean create powerful, complex currents, with surface and deep waters flowing in opposite directions. Weather in Gibraltar is highly unpredictable. Westerly poniente winds and easterly levant winds can collide, creating sudden storms. Ships must closely monitor conditions before crossing. Gibraltar is a British overseas territory, despite sitting on Spain's doorstep. A centuries-long sovereignty dispute between the UK and Spain remains unresolved, further complicated by Brexit. For NATO, Gibraltar is a vital gateway. Controlling the strait means controlling the flow between the Atlantic and the Mediterranean, from the Americas to the Middle East. Tens of thousands of ships pass through Gibraltar every year, linking Europe to the Mediterranean and beyond. It is a vital trade route, especially for economies dependent on energy imports. Gibraltar is more than a strait, it is a symbol of maritime power through the ages. Whoever controls it controls the gateway between East and West, a position that remains unchanged today. No strait in the world is as iconic as the Bosphorus. Just 31 kilometers long and less than 700 meters wide at its narrowest point, it divides Istanbul in two and separates Europe from Asia. The Bosphorus features a unique two-layer current system. Less saline water from the Black Sea flows on the surface toward the Marmara, while denser, salter water flows in the opposite direction below. This creates unique underwater conditions. Few straits pass directly through a megacity like the Bosphorus. Massive oil tankers travel just hundreds of meters from dense residential areas. A single accident here could trigger an immediate disaster for millions. The Bosphorus, together with the Dardanelles, forms the only outlet from the Black Sea. Countries like Russia, Ukraine, and Romania depend on this route to access global waters. It is a powerful geopolitical leverage point. The Montreux Convention of 1936 grants Turkey control over the Bosphorus. Ankara can restrict or close the strait to foreign warships during times of conflict. It is one of the most unique strategic powers in the world. During the Russia-Ukraine war, the Bosphorus became a global diplomatic focal point. The Black Sea grain deal allowed Ukraine to export food through the strait, preventing hunger for tens of millions. The Bosphorus directly impacts global food supply. Beyond its surface, the Bosphorus is also connected beneath. The Marmara Tunnel runs 60 meters below the seabed, linking European and Asian rail networks. It stands as a remarkable feat of modern engineering. The Bosphorus is not just a shipping route, it is the geopolitical heart of Turkey. Ankara leverages control of the strait to balance relations between NATO and Russia, maintaining strategic influence during global crises. Over 40,000 ships pass through the Bosphorus each year, more than the Suez Canal. Oil, gas, grain, and goods all move through this narrow waterway cutting through a megacity. It is one of the busiest and most complex straits in the world. At the far north, where Alaska and Siberia are just 86 kilometers apart, lies the Bering Strait, a natural boundary between the United States and Russia. In winter, temperatures drop to minus 30 degrees Celsius, and ice covers almost the entire surface. It is one of the harshest seas on Earth. For most of history, the Bering Strait has been nearly unusable for commercial shipping. Blizzards, dense fog, and thick ice make navigation extremely dangerous. Only specialized fleets, particularly from Russia, operate here regularly. Climate change is transforming everything. Arctic ice is melting at an unprecedented rate, with summer ice coverage down more than 40% compared to the 1980s. New shipping routes are beginning to emerge. The Arctic route through the Bering Strait can shorten travel between Europe and Asia by up to 40%. A journey from Rotterdam to Tokyo could take around 15 days instead of 25. This translates into billions of dollars in savings each year. The Bering Strait is becoming a new arena of competition between the United States, Russia, and increasingly China. Whoever controls this region may control future trade routes and vast Arctic resources. The Bering Strait reminds us that nature is changing, and with it, the global balance of power. A once-forgotten passage is emerging as a future shipping route, bringing both opportunity and new conflicts. Looking back, each strait has completely distinct natural characteristics. Hormuz is shallow and narrow. Malacca is tropical and complex. Gibraltar has powerful currents. The Bosphorus features two opposing water layers. Bering is frozen and harsh. These differences define their unique value and risks. These straits do not exist in isolation. They are nodes in a global trade network. A disruption at any point can trigger a chain reaction, from financial markets to the daily lives of billions. Control over strategic straits directly influences global negotiations. They are bargaining chips in economic, military, and geopolitical alliances. Whoever controls these gateways holds greater influence over the world order. From space, Earth appears as a water planet. Yet these narrow passages shape the destiny of 8 billion people. Straits are not just pathways for ships. They are where history is written and the future is shaped. At sunrise, the Persian Gulf looks as if nothing has ever happened here. The surface is calm, silent, endless. But beneath that still water, beneath hundreds of meters of sediment and ancient rock, lies something that has shaped modern human history for more than a century. The Arabian Sea spans more than 3.8 million square kilometers. Most of its seabed has never been touched, fully mapped, or drilled by humans. It remains one of the least understood regions on Earth, and potentially one of the richest yet to be explored. In these shallow waters, oil has been discovered and extracted for more than 80 years. The Middle East's first oil wells lie just beneath, shallow, accessible, easy to reach. But the easy resources are running out. And human ambition is now moving farther and deeper. This is a boundary humans have seen for thousands of years without understanding its geological meaning. The color shifts because the seabed suddenly drops hundreds of meters. On one side lies the continental shelf, explored and known. On the other lies the deep ocean, where the real secrets remain. At night, the ocean guards its secrets even more carefully. No aircraft can see through it. No satellite can penetrate its depths. What lies beneath is safer than any vault on land. And that is exactly why the most critical explorations happen in silence, often under the cover of darkness. From June to September, the southwest monsoon turns the Arabian Sea into a nightmare. Waves reach up to 5 meters, visibility drops near zero, and underwater currents become unpredictable. Deep-sea exploration is limited to the remaining 8 months, and every calm day comes at a cost. 50 meters deep, sunlight still exists. Colors still exist. Life still exists. But as you go deeper, everything changes. Light fades. Colors disappear. And at a few hundred meters, it becomes a world where humans cannot survive without machines. This is what oceanographers call the twilight zone, where the last traces of light disappear. Below lies only darkness, pressure, and absolute silence. And in a place untouched by sunlight, beneath thousands of meters of cold water, ancient hydrocarbon deposits may still remain, undisturbed since their formation. At 200 meters deep, the world is completely different. Pressure is 20 times that at the surface. Temperatures drop to 7 to 10 degrees Celsius. A fine layer of sediment stretches endlessly like an underwater desert. And beneath it, Earth's geological history is recorded layer by layer. Each meter deeper represents thousands of years. This is the edge of the continental shelf, where land ends and the abyss begins. These cliffs rise hundreds of meters, nearly vertical, recording hundreds of millions of years of geological history in stone. Geologists read them like treasure maps, searching for signs of hydrocarbon traps hidden below. At 1,500 meters, pressure reaches 150 times atmospheric levels, enough to crush human bones instantly. Temperatures approach freezing. No light, almost no currents. Yet within this pale sediment, methane molecules sometimes seep upward, a signal that something lies deeper below. These bubbles are not random. Methane seepage is the clearest geochemical signal of hydrocarbons below, like smoke revealing fire. In the deep Arabian Sea, such seeps have been recorded in multiple locations. Each stream of bubbles is an arrow pointing downward, toward the answer. Hydrothermal vents reveal intense geothermal activity beneath the seafloor. This activity is part of the long process that forms oil over millions of years. Where the Earth is still hot, where the subsurface is still active, the conditions for hydrocarbon formation may still exist. Not only in the past, but even today. Each sediment layer is a page of history. Brown marks shallow, life-rich seas. Gray signals deep, oxygen-poor waters. Black layers contain organic material, the precursor to oil. Geologists read these cores and witness hundreds of millions of years unfold before them. Even in total darkness, life persists. These creatures have evolved over millions of years to survive conditions humans cannot endure. The deep ocean is not lifeless. It is a complex, fragile ecosystem. Cold water corals live at depths of hundreds to thousands of meters without sunlight. They grow slowly, live for thousands of years, and support entire ecosystems. Yet they remain invisible to the surface world until human activity reaches them. At 4,000 meters, the seafloor is flatter than any land plane. Red sediment accumulates incredibly slowly, less than 1 millimeter per thousand years. This is one of the quietest places on Earth. And beneath it, seismic data suggests massive geological structures that may have never been explored. This seismic vessel is mapping what lies beneath the seabed using sound waves. Air guns fire powerful pulses downward, through water, mud, and rock, before they reflect back. This is how humans see through thousands of meters into the Earth. These streamers stretch up to 12 kilometers, longer than Mount Everest is tall if stood upright. They carry thousands of ultrasensitive sensors, detecting vibrations far beyond human perception. A single day of data can reach millions of gigabytes, more than entire national libraries. Every 20 seconds, air guns fire, releasing pressure waves traveling at 1,500 meters per second. When they hit boundaries between rock layers, part of the signal reflects back. From this, scientists reconstruct a three-dimensional image of the subsurface. Semi-submersible rigs operate in waters up to 3,600 meters deep. From the platform, a drilling column kilometers long is lowered like a needle through water and into the earth. It is one of the most complex engineering systems ever built to find oil. The ROV is the human eye and hand in the deep ocean. Weighing several tons and protected by titanium, it connects to the surface through a thin fiber optic cable. Data and images stream back in real time with almost no delay. A movement that seems simple, but performed at 2,000 meters under crushing pressure. Operators control robotic arms with millimeter precision. This 1-meter core sample could hold answers worth billions of dollars. An FPSO processes, stores, and offloads oil entirely at sea. Can handle hundreds of thousands of barrels per day. In contested waters, its mobility becomes a strategic advantage fixed platforms cannot match. Each kilometer of deep-sea pipeline can cost over $10 million. These lines stretch hundreds of kilometers, linking wells to ships or shore. Repairing them is as complex as rebuilding a skyscraper underwater. Not every vessel at sea belongs to oil companies. Some are research ships operating quietly, collecting data never made public. And it is precisely that hidden data that raises the most questions. The Strait of Hormuz, a narrow stretch of water less than 50 kilometers wide at its narrowest point. Yet every day, around 21 million barrels of oil pass through it. Tankers move in organized lanes like highways at sea, carrying the energy that fuels the global economy. This is not just a shipping route, it is the main artery of the modern world. A VLCC, a very large crude carrier, can transport up to 2 million barrels of oil in a single journey. Stretching over 300 meters and weighing more than 300,000 tons fully loaded, these ships move slowly like drifting mountains. Their immense inertia means they require up to 8 kilometers to come to a full stop. Every day, hundreds of these giants silently carry energy across the planet. It is no coincidence that the world's most powerful navies maintain a presence here. Every oil shipping route is a strategic corridor that must be protected. Every offshore platform is a potential target. In these waters, energy and military power are inseparable. This is conflict without gunfire. A vessel appears not to attack, but to assert presence, to signal ownership over the waters. And whenever geological data begins to reveal valuable resources, these silent confrontations become more frequent. The flames burning atop offshore platforms are flared gas. Natural gas released alongside oil but burned due to lack of transport infrastructure. From space, these flames glow like artificial stars. Each one is a clear signal oil is being extracted below. In deep waters, such flames have yet to appear, but that may soon change. On maps, maritime borders are just straight lines. In reality, they are invisible. Water does not recognize ownership. Fish do not carry passports. But when oil lies beneath disputed zones, those invisible lines become boundaries worth billions, and suddenly they matter immensely. This is a common scene in disputed waters. A survey vessel enters a contested zone and is quickly intercepted. No weapons, no collision. Just a clear message. The data beneath this seabed is not meant to be shared. From the deck of a drilling vessel in the Arabian Sea, there is no land in sight, only endless water and sky. But beneath the ship, a drill string descends thousands of meters into the earth, searching for something that could reshape an entire region, or perhaps nothing at all. Hormuz is one of the busiest maritime routes on Earth. Hundreds of vessels pass through it daily. And if a new deep-sea oil field is confirmed to the south, that number will rise significantly. More opportunity, but also more risk. The Arabian Sea during storm season is one of the harshest environments for engineering on Earth. Waves rise to extreme heights, winds exceed 100 kilometers per hour, and underwater currents shift unpredictably. These forces can destroy any structure not built to perfection. It is one of the reasons why these deep waters remain largely unexplored. On the open ocean, every vessel is supposed to have an identity. But sometimes, there are ships that choose not to be seen. No clear flag, no AIS signal. They move through the darkness, appearing and disappearing from global tracking systems. And most notably, these gaps often occur in the deep Arabian Sea. AIS tracking systems can detect nearly every ship on Earth, but they are not perfect. Those who understand the system know exactly when and where to disappear. A vast stretch of ocean with no signals, no traces, in one of the world's most critical maritime regions. And that is no coincidence. At night, satellites reveal the truth most clearly. The Persian Gulf glows with hundreds of lights from offshore platforms and vessels. But beyond it, the Arabian Sea fades into complete darkness. No lights, no recorded activity. But in the world of energy, silence rarely means absence. It often means concealment. Beneath the surface, another world operates unseen. Military submarines move silently, collecting data, tracking signals, listening to every movement. In the deep-sea energy game, geological intelligence is as valuable as military intelligence. And nations are willing to go to great lengths to obtain it first. Sea fog hides everything, much like the world of deep-sea oil. The ships, the money, the power, it is all there. But no one sees the full picture. Each side sees only a fragment, or only what they are allowed to see. And within that fog, decisions are made that can reshape entire regions. From the Arabian deserts, massive sandstorms can sweep hundreds of kilometers out to sea, erasing visibility entirely. Surface operations come to a halt. But thousands of meters below, there is no storm, no wind. What lies beneath the seabed remains untouched by the chaos above. It has been there for millions of years, waiting. At sunset, offshore rigs appear almost beautiful, like silhouettes against a burning sky. But beneath that beauty lies a different reality. These machines drill deep into the earth, extracting resources that took millions of years to form. And every barrel brought to the surface is a piece of the past that will never return. Above the ocean, surveillance aircraft monitor every movement below. Every vessel, every platform, every anomaly is recorded. The data is analyzed, compared, and stored. In this world, almost nothing remains truly hidden, except for one thing: what lies deep beneath the seabed. From above, the Arabian Sea at dawn appears untouched by human hands. A flawless mirror reflecting a pale pink sky. Yet beneath that calm surface lie billions of tons of hydrocarbons, resting for hundreds of millions of years. The question has never been whether they exist, but who will claim them, and at what cost. The sea knows nothing of oil, nothing of money or power. It simply does what it has always done, moving, eroding, and reshaping the world. And when humanity is gone, the ocean will erase every trace. The only question is, before that happens, how much will we take? Every oil platform has an end. When the reserves run dry, these massive steel structures are dismantled, cut apart, and removed. The cost can reach billions of dollars. But what has been extracted never returns. On the seabed, only traces remain, steel memories of what once stood. Out at sea, there are moments when all boundaries disappear. Water and sky merge into a single horizon. And somewhere beneath that line, the answers remain hidden. Not in maps, not in political agreements, but within the silent layers of sediment far below. At sunset, the Arabian Sea becomes a breathtaking canvas of light, beautiful enough to make one forget what lies beneath. But as the light fades, darkness takes over. And in the depths where sunlight never reaches, the secrets remain untouched, waiting for those bold enough to uncover them. Night falls, and the ocean returns to its true nature: dark, deep, and endless. What lies beneath does not disappear. It only becomes quieter, more patient. The story of oil is not over. It is simply shifting, from desert sands to ocean depths, and the seabed has not yet told its full story. On the world map, there is a narrow strip of water less than 33 kilometers wide, so small it is easy to overlook. Yet every day, 30% of the world's oil passes through here. It is called the lifeline of civilization. Every day, around 21 million barrels of oil silently pass through here, carried by massive tankers longer than 3 football fields. They come from the oil fields of Arabia and travel to every corner of the world. There is no alternative route. The Strait of Hormuz lies between Iran and the Arabian Peninsula, a single gateway connecting the Persian Gulf to the Indian Ocean. Its full width is 33 kilometers, but the actual shipping lanes are only about 3 kilometers each way. It is one of the most closely monitored geographic spaces on Earth. Thousands of years ago, Arab traders sailed these waters, carrying spices, pearls, and silk to India. Hormuz was once an independent trading empire where sea routes converged. Its role has changed, but its importance has never diminished. The human body can survive weeks without food and days without water, but only minutes without breathing. The global economy is the same. It can endure many shocks, but it cannot survive if Hormuz is closed. That is why this place is called the throat of the world. "21 million barrels of oil. That is what the Strait of Hormuz must digest every single day. If poured into Olympic swimming pools, it would fill over 30,000 of them. No other oil transit route on Earth comes close to this scale. China is the world's largest oil importer, and much of it must pass through Hormuz. Every factory running, every car moving, every building being heated in China is tied to this narrow stretch of water. It is a geographic dependency Beijing has never been comfortable with. Japan imports over 90% of its oil through Hormuz. With no significant domestic energy and no pipeline alternatives, it relies entirely on tankers and a single strait. South Korea faces a similar reality. For both nations, Hormuz is not a choice, it is geographic destiny. If supply through Hormuz is disrupted for just a few days, global oil prices could surge by tens of % within 24 hours. And when oil rises, everything rises: transport, manufacturing, food, electricity. The global supply chain tightens like a body cut off from its blood flow. We often think of oil as fuel for cars or planes. But it is also the foundation of plastics, fertilizers, pesticides, paints, synthetic fabrics, and thousands of other products. Half the items in the room you are in contain petroleum derivatives. Hormuz doesn't just carry fuel, it carries modern industry itself. India, one of the fastest-growing economies in the world, is also increasing its dependence on Gulf oil. The Jamnagar refinery processes over 1 million barrels a day, most of it arriving through Hormuz. The prosperity of hundreds of millions of Indians is anchored to a strait thousands of nautical miles from Mumbai. The northern shore of the strait belongs to Iran, the country that controls much of this strategic waterway. From here, every passing vessel is within sight, radar range, and if necessary, missile range of Tehran. It is one of the rare geographic advantages Iran holds in the global geopolitical game. Along Iran's coastline, anti-ship missiles like Noor and Khalij Fars are positioned on rugged mountain terrain. They can strike targets hundreds of kilometers away, and within the narrow confines of Hormuz, no vessel can escape their range. This is asymmetric warfare, low cost, high destructive impact. Iran does not rely only on exposed weapons. Inside coastal mountain ranges, underground bases carved into rock-house fast boats, missiles, and command centers. Satellite imagery cannot fully reveal them. Conventional bombs cannot easily penetrate them. This is a hidden card Iran holds, and its adversaries know it well. A $13 billion U.S. aircraft carrier can be overwhelmed by hundreds of small speedboats worth only tens of thousands each. This is the swarm tactic Iran has practiced for decades, attacking simultaneously from all directions with speed and overwhelming numbers. In the narrow waters of Hormuz, traditional technological superiority becomes ineffective. Beneath the strait, where no human eye can see, Iran could deploy thousands of naval mines within hours. A single mine can tear open the hull of a supertanker. And once a few ships are damaged or sunk, the entire route can be shut down, not by force but by fear. It is one of the most effective psychological weapons in Hormuz. In response, the United States Navy maintains a constant military presence in the Gulf and the Strait. The Fifth Fleet, based in Bahrain, patrols 24/7, with ships, radar, and satellites tracking every movement. It is a never-ending mutual surveillance, and both sides know a single mistake could trigger disaster. What sounds like a hypothesis has already happened multiple times. In 2019, several oil tankers were attacked near Hormuz, their hulls breached and crews thrown into panic. Oil prices spiked instantly, and global financial markets trembled. Just a few attacks, without full-scale war, were enough to trigger worldwide economic anxiety. In summer, temperatures in Hormuz can exceed 50 degrees Celsius. The sea becomes a mirror reflecting intense heat, and metal surfaces on ships can burn skin on contact. Crews work in conditions nearly beyond human tolerance, while electronic systems frequently fail under extreme temperatures. From the Arabian desert, massive sandstorms regularly sweep into the strait, reducing visibility from kilometers to zero within minutes. Navigating a 330-meter-long tanker through a 3-kilometer channel without sight is a challenge captains must face. Radar becomes the only eye, yet even it can be disrupted in the storm. Hundreds of oil tankers operating simultaneously, burning low-grade heavy fuel, create a persistent haze over the strait. Combined with high humidity from the sea and desert sand, the air becomes dense and hazardous. It is one of the most polluted marine regions on the planet. A supertanker requires 3 to 5 kilometers to come to a full stop. In Hormuz's narrow 3-kilometer shipping lane, that means there is no margin for error. Captains must make split-second decisions, relying on years of experience and nerves of steel. A single collision could sink hundreds of millions of dollars and trigger a devastating oil spill in these confined waters. At the gateway of the strait, Hormuz Island appears like a work of art from above. Vivid red soil rich in iron oxide, interwoven with streaks of white, yellow, purple, and orange. It is known as the Rainbow Island. Beneath these extraordinary colors lies a history of thousands of years, when this region was once a global trade hub. The people of Hormuz do something few places in the world can claim. They eat the earth. This red soil, rich in iron oxide and minerals known as galak, is mixed into bread, used as a seasoning, or even eaten on its own. It is not poverty, but a unique culinary tradition deeply connected to the island's unusual geology. Every morning, fishermen set out to sea on small wooden boats, following traditions passed down for centuries. And every morning, they share the water with steel giants over 300 meters long, carrying oil for the global economy. Two worlds could not be more different, yet they coexist on the same narrow stretch of water. Bandar Abbas, a city of 500,000 on the northern shore, exists because of Hormuz and lives through it. Its port is Iran's main trade gateway, where goods from around the world arrive and Iranian oil flows out. For the people here, geopolitics is not abstract. It is their jobs, their income, and their daily lives. As the sun sets behind anchored oil tankers, Hormuz reveals a breathtaking beauty, red, orange, and purple blending across the calm sea. It is a moment where grandeur and fragility coexist. The pure beauty of nature, and beneath it, the ever-present tension of geopolitics. Saudi Arabia and the UAE have built pipelines across the desert to reduce dependence on Hormuz. But their total capacity can only handle about 20% of the required oil flow. The remaining 80% has no route except the strait. And building more pipelines? It would cost hundreds of billions of dollars, take decades, and face nearly insurmountable terrain challenges. In theory, tankers could reroute around the Cape of Good Hope in Africa. But that would add thousands of nautical miles, weeks of travel, and dramatically higher costs. Oil prices would rise 10 to 15% from transport alone, and the world would need twice as many tankers. It is not impossible, just too expensive to be practical. The world is transitioning toward renewable energy, but far more slowly than headlines suggest. Oil will still dominate global energy at least until the mid-21st century. During this transition, Hormuz remains irreplaceable. Dependency does not disappear overnight, it fades gradually over decades. Experts have modeled a scenario where Hormuz is closed for just 48 hours. Within the first 6 hours, global financial markets begin to tremble. By hour 24, oil prices could exceed $200 per barrel. By 48 hours, some Asian governments may convene emergency cabinets. No war is needed, just 2 days of closure. Globalization has created unprecedented prosperity, but it has also created critical vulnerabilities. Hormuz is the clearest example. A $100 trillion global economy depends on a narrow 33-kilometer strip of water. That is not strength, it is fragility dressed as prosperity. Every oil tanker that passes safely through Hormuz is the result of a delicate balance between Iran and the United States, between Saudi Arabia and its neighbors, between geopolitical calculations and economic interests. Peace here is not luck. It is the product of constant restraint, day after day. And that restraint can break at any moment. Modern civilization is built on energy, and that energy must pass through Hormuz. We have created megacities, global supply chains, and complex transport networks, all relying on the uninterrupted flow through a strait narrower than a single city. It is one of the greatest contradictions of our time. Every morning, Hormuz awakens and continues its work, quiet, unseen, yet indispensable. As long as the world needs oil and economies remain interconnected, this strait will remain a crossroads of destinies. A narrow 33-kilometer strip of water, small on the map, yet carrying the weight of an entire civilization. The stretch of ocean between Florida, Puerto Rico, and Bermuda became known as the Devil's Triangle, a name that sent chills down people's spines. Dozens of ships and aircraft vanished here without a trace. And the most famous story began on December 5, 1945. It was an ordinary afternoon at the naval base in Fort Lauderdale. 5 Avenger torpedo bombers were carefully inspected and ready for takeoff. The mission was only a routine training exercise expected to last about 2.5 hours. Leading the squadron was Lieutenant Charles Taylor, an experienced pilot with hundreds of flight hours. With him were 13 younger pilots and navigators. None of them knew this would be their final flight. At 2:10 p.m., Flight 19 took off and headed east over the Atlantic Ocean. For nearly 2 hours, everything went normally. There was no sign of what was about to happen next. At 3:45 p.m., the control tower received a transmission from Taylor. The compasses were malfunctioning. He could no longer determine where west was. The ocean below looked strange in a way he could not explain. Taylor reported, "We don't know where we are. The ocean doesn't look as it normally should." There was no land, no islands, no point of reference. only the endless ocean stretching in every direction. The other pilots began arguing over which direction to fly. Some believed they should head west, others thought south. Taylor insisted on staying the course, convinced they were flying over the Gulf of Mexico. As fuel levels dropped toward empty, Taylor ordered the squadron north in search of land. But every change in direction only carried them farther from shore. Darkness was closing in. At 5 p.m., the radio signal grew weak and broken. Taylor's final recorded words were, "Keep all planes close together. When the first plane runs out of fuel, we all go down together." Then silence. Five Avenger aircraft and 14 men vanished into the night over the Atlantic Ocean. No wreckage, no bodies, and no distress signal were ever found. Flight 19 became legend. As soon as Flight 19 lost contact, the U.S. Navy dispatched 2 PBM Mariner rescue aircraft. These long-range patrol planes were specially designed for search missions over the sea. But the unimaginable was about to happen. Just 23 minutes after takeoff, one of the 2 rescue aircraft completely lost contact with the control tower. The tanker SS Gaines Mills reported seeing a large fireball in the dark sky. Yet no trace was ever found afterward. A total of 27 men disappeared in a single day, an unprecedented tragedy in American civilian and military aviation history. The search continued for days but produced no results. The U.S. Navy Investigation Board concluded, "Cause unknown." It was a diplomatic phrase for something they truly did not understand. That conclusion only fueled the mystery surrounding the Bermuda Triangle. No family received the body of a loved one for burial. No satisfying answers were ever given. Pain and mystery remained intertwined for decades afterward. Flight 19 became a wound that never healed. Three years after Flight 19, in January 1948, the Tudor IV airliner Star Tiger departed from the Azores bound for Bermuda. It was a routine commercial passenger flight across the Atlantic Islands. With less than 2 hours remaining before reaching Bermuda, Star Tiger suddenly went silent. There was no distress signal and no message from the crew. A 5-day search found no wreckage at all. The British Investigation Board declared, "What happened to Star Tiger remains an unsolved mystery." That same year, another aircraft would vanish in nearby waters under similarly mysterious circumstances. In December 1948, a Douglas DC-3 with registration NC 16002 departed from San Juan bound for Miami. On board were 31 people, 27 passengers, and 4 crew members. They never arrived. The pilot sent a final message when only 50 miles from Miami, reporting that everything was normal and the city lights were visible. Then silence. Not a single piece of wreckage was ever found despite a massive search effort. One of the most common theories involves magnetic anomalies in the Bermuda Triangle. The seafloor here contains mineral deposits with strong magnetic properties, especially magnetite. These could cause magnetic compasses to drift by several degrees. In 1945, aircraft and ships depended entirely on magnetic compasses for navigation. There was no GPS and no satellite positioning system. If the compass was wrong, pilots had no reliable way to confirm their true location. Charles Taylor himself reported that the compasses were malfunctioning. He believed he was flying over the Gulf of Mexico when he was actually over the Atlantic Ocean. A small navigational error, multiplied over hours of flight, became fatal. Modern studies confirm that localized magnetic anomalies exist in parts of this region. But they are not strong enough to seriously affect modern equipment. With the crude instruments of the 1940s, however, the consequences could have been far more severe. Many scientists consider this the most plausible explanation for Flight 19. Not the supernatural, not aliens, just basic physics and outdated technology placed in an unforgiving situation. The seafloor beneath the Bermuda Triangle may contain giant methane pockets formed from the decay of ancient organisms. When pressure builds high enough, they can erupt suddenly and violently toward the surface. When a large volume of methane suddenly rises, the density of the water drops instantly. Large ships could lose buoyancy at once and sink straight down before sending a distress call. This could explain why no floating wreckage is sometimes found. For low-flying aircraft, methane entering the engine system could cause engine failure. Flames from the engines meeting a methane cloud could trigger an immediate explosion. This theory attempts to explain the disappearance of both ships and aircraft. Geologists have confirmed the presence of methane hydrates in this region. Some studies, including research published in 2003 by Australian scientists, suggest that major gas eruptions in the past may have been powerful enough to sink medium-sized ships within minutes. However, no accident has ever been directly observed and conclusively linked to a methane eruption. The theory remains under investigation and has not been fully proven. The Bermuda Triangle lies within one of the most active tropical storm regions on Earth. Storms over the Atlantic Ocean can form and intensify rapidly here, sometimes within only a few hours. Massive waves combined with violent winds can sink small and medium ships within minutes. For aircraft, turbulent air from storms can cause total loss of control. In 1945, there was no weather radar, so pilots had no way of knowing where storms were. On the day Flight 19 vanished, weather reports indicated rapidly changing conditions by late afternoon. There were no early warning systems and no real-time data. Pilots could fly directly into a storm without realizing it. One lesser-known factor is the rogue wave, giant walls of water that appear suddenly without warning. Reaching heights of up to 30 meters, they can rise in calm seas and destroy everything in seconds. Data from NOAA confirms that the Bermuda Triangle is one of the most meteorologically unstable regions on Earth. This factor alone may explain the majority of reported disappearances. Before the GPS era, navigating over the ocean required great skill and was highly prone to error. Pilots had to determine position through celestial navigation, measuring stars, calculating by hand, and relying on clear skies. Charles Taylor was an experienced pilot, but he had limited flying time east of Florida. Investigators believe he misidentified the islands below him. Instead of recognizing the Bahamas, he believed he was seeing the Florida Keys. When Taylor turned north based on that mistaken belief, the squadron moved farther into the Atlantic Ocean. Fuel ran out before anyone could correct the error. It was a tragedy created by human misjudgment, not supernatural forces. Taylor's family rejected that conclusion. They believed he was an exceptional pilot who could not have made such a basic mistake. But even the most skilled professionals can fail under stress and limited information. This was the harsh reality of pre-GPS aviation. Lack of information leads to wrong judgment leads to wrong decisions, and wrong decisions over a dark ocean leave no chance for recovery. The Bermuda Triangle became a pop culture phenomenon in the 1970s when Charles Berlitz published The Bermuda Triangle, which sold more than 20 million copies worldwide. He combined many disappearances from different locations into one supernatural narrative. What few people know is that Lloyd's of London, the world's most famous maritime insurer, does not charge higher premiums for vessels crossing the Bermuda region. If it were truly abnormally dangerous, they would have known first. In 1975, researcher Lawrence David Cush examined each disappearance cited by Berlitz. He found that many occurred outside the triangle, some were exaggerated, and some were entirely fabricated. When disappearance rates are adjusted for the density of ship and aircraft traffic, the Bermuda Triangle is not exceptional. The Mediterranean Sea, the South China Sea, and waters around Japan actually show higher accident rates. In 2010, NOAA stated that there is no scientific evidence showing accident rates in Bermuda are higher than normal. The legend had grown larger than reality. Most experts today agree on a combined explanation. Severe weather, navigational mistakes, outdated technology, and harsh ocean conditions are the true causes. No supernatural force is required. Every year, thousands of flights and tens of thousands of ships pass safely through the Bermuda Triangle. With GPS, radar, and satellite communication, this region is no more dangerous than anywhere else. The seafloor of the Bermuda Triangle has been surveyed in detail using modern sonar technology. No strange structures or signs of mysterious forces have been found. Only the normal geology of a tropical ocean basin. The real mystery is not the disappearances, but why people so deeply want to believe in mysteries. We search for extraordinary stories in a world where ordinary explanations often feel less satisfying than legend. The Bermuda Triangle will remain a symbol of mystery in human culture, not because it is more dangerous than other seas, but because it reminds us that the ocean is vast, majestic, and still not fully understood.
This is the darkest place on our planet. Not outer space, not a cave, not the depths of a forest. It lies directly beneath your feet, 11 kilometers below the ocean's surface. Sunlight can only penetrate the first 300 meters of the ocean. Below that lies the twilight zone, then the midnight zone, and finally, absolute darkness. Challenger Deep is 36 times deeper, where no ray of sunlight has ever reached. If Mount Everest were placed inside the Mariana Trench, its peak would still sit 2 kilometers underwater. This is the lowest point on Earth's surface. And for centuries, humanity knew almost nothing about it. More people have walked on the moon than have visited the deepest ocean. Challenger Deep is more remote than the International Space Station. And what scientists discovered there could change how we understand life forever. Scientists discovered life here. Not fragile organisms barely surviving, but entire ecosystems thriving and stranger than anything imagined on distant planets. This is the story of Earth's deepest abyss and its final mystery. The Mariana Trench lies in the western Pacific Ocean, about 300 kilometers from the island of Guam. It stretches for 2,550 kilometers, longer than the width of the United States. But its true fame comes from its unimaginable depth. Earth's surface is divided into massive tectonic plates that constantly move.
Here, the older and heavier Pacific Plate dives beneath the smaller Mariana Plate, tearing the ocean crust apart and forming the deepest scar on the planet.
What makes the Mariana Trench so deep is the age of the ocean crust. It is 170 million years old. Dating back to the age of dinosaurs. Older crust is colder, denser, and sinks deeper into the planet. From the surface to 200 meters lies the sunlight zone. Home to dolphins, sharks, and coral reefs. Below 1,000 meters begins the midnight zone, where darkness and crushing cold dominate. But beyond 6,000 meters lies the Hadal zone. A strange world where pressure reshapes the rules of life itself. The pressure at Challenger Deep is more than 1,000 times stronger than at sea level. It's like placing 50 Boeing 747 airplanes on an area the size of your fingertip. Any object not specially reinforced would be crushed instantly. Temperatures at the bottom range between just 1 and 4 degrees Celsius, nearly freezing. No sunlight reaches this depth, and no warm ocean currents can penetrate it. This is the coldest, darkest, and most silent environment on Earth. You sit inside a steel sphere smaller than a refrigerator. Outside, 11 kilometers of freezing seawater press against every centimeter of the hull. And the only sound you hear is the metal creaking under unimaginable pressure. On January 23, 1960, two men prepared to attempt something no one had ever done before. U.S. Navy Lieutenant Don Walsh and Swiss engineer Jacques Piccard were about to descend to the deepest point on Earth. The Trieste was unlike any submarine ever built. Above sat a massive tank holding 85,000 liters of gasoline for buoyancy. Below hung a steel sphere 12 centimeters thick, barely 2 meters wide. No cameras, no robotic arms, no rescue system, just two men and a mission. The descent lasted 4 hours and 47 minutes in total darkness. Walsh and Piccard could see nothing, only hearing the water, each other's breathing, and the creaking of metal.
Then, at 9,000 meters, a terrifying bang echoed through the hull.
A plexiglass window on the outside had cracked under pressure, shaking the entire vessel. Walsh and Picard faced a choice: ascend immediately or continue descending deeper. They looked at each other and made their decision: to keep going. At 1:06 p.m., the Trieste touched the bottom of Challenger Deep at a depth of 10,916 meters. The temperature inside the cabin had dropped to just 7 degrees Celsius. Exhausted and shivering, they had only 20 minutes before beginning the ascent. Picard reported seeing a flatfish about 30 centimeters long gliding slowly across the sediment. Then small shrimp appeared. Movement, life. Perfectly ordinary life at the very bottom of the abyss. Challenger Deep was not empty. Something was living there. After that historic dive, no one returned to Challenger Deep for more than 50 years. The Trieste carried no cameras and collected no samples. 2 eyewitness accounts were the only evidence. The US Navy abandoned the effort. The cost was enormous, and the scientific return seemed too small. Scientists shifted to using remotely operated vehicles, or ROVs. These machines could send back images and samples, but they lacked the flexibility of human exploration. The Mariana Trench remained largely forgotten until a Hollywood director entered the story. On March 26, 2012, filmmaker James Cameron climbed inside the submersible Deep Sea Challenger. The director of Titanic and Avatar was about to descend alone to the deepest point on Earth. This time, there were cameras, scientific instruments, and tools to truly study the abyss. Cameron sat inside a cockpit so cramped he could barely stretch his arms. A window 24 centimeters thick separated him from the crushing pressure outside. After 2 hours and 36 minutes, he became the 3rd human in history to reach Challenger Deep. Cameron described the landscape as desolate, almost like the moon. No large animals appeared, yet the sediment samples he collected revealed 68 previously unknown species of microbes. Cameras also captured microbial mats thriving through chemosynthesis, life that survives without sunlight. In May 2019, American explorer Victor Vescovo reached a record depth of 10,927 meters. But he did not stop after one dive. Vescovo returned repeatedly, allowing humans for the first time to systematically explore the deepest part of the ocean.
Vescovo's team discovered rocks coated in vivid yellow and orange minerals, evidence of deep geological activity. They also identified 4 new species of amphipods, shrimp-like creatures perfectly adapted to the crushing pressure of the abyss. Then, Vescovo saw something no one wanted to find in the deepest place on Earth. Resting on the floor of Challenger Deep, nearly 11 kilometers below the surface, was a plastic bag and candy wrappers. He later described it as the most disappointing moment of the entire expedition. Scientists brought the captured deep-sea creatures back to the laboratory and analyzed their tissues. The results were shocking. Nearly every animal examined contained microplastics. Plastic from the surface had sunk 11 kilometers down, and the creatures here are consuming it. This discovery shocked the scientific community. No part of the ocean, no matter how deep or remote, remains untouched by human activity. The Mariana Trench is not only the deepest place on Earth, it has also become a mirror reflecting humanity's impact on the planet. The Mariana snailfish is the deepest living fish ever recorded, surviving at depths beyond 8,000 meters. Its body is almost transparent, lacking a swim bladder and built mostly from soft cartilage. It represents the absolute limit of vertebrate life on Earth. Giant amphipods, relatives of shrimp, can grow up to 18 centimeters in the Mariana Trench. Scientists discovered they reinforce their exoskeletons with aluminum, something no other known animal does. They extract the metal directly from deep-sea sediments. The Dumbo octopus, named for its ear-like fins, is one of the deepest living octopus species known. Unlike shallow water octopuses, it lacks an ink sac. At these depths, predators are rare, so elaborate defense mechanisms are unnecessary. Xenophyophores are the largest single-celled organisms ever discovered. A single cell can grow to the size of a tennis ball. Spread across the ocean floor like alien flowers, they challenge many biological assumptions about the limits of life. Between August and November 2021, China's Fendaoxia submersible completed 33 dives into the Mariana Trench. Scientists collected more than 1,600 sediment samples and discovered over 7,000 microbial species, nearly 89% of them previously unknown to science. Thousands of tube worms and giant clams form dense colonies on the trench floor, resembling an underwater forest. These organisms survive through chemosynthesis, using chemical energy leaking from the Earth's crust instead of sunlight. It is the deepest chemosynthetic ecosystem ever discovered. The Mariana Trench teaches us something extraordinary. Life does not require sunlight, comfortable temperatures, or the conditions we once believed were essential. But it also teaches us something else. No place on Earth is truly beyond the reach of humanity. Even 11 kilometers beneath the ocean's surface, our presence can be found. The darkest place on our planet is still waiting to be explored. The only question is this: when we return, will we bring science or more pollution? You look at the ocean's surface and think you are seeing the Atlantic, but that surface is only a curtain, a thin sheet of glass separating our world from an entirely different one below. "99% of this ocean's volume exists where there is no light, no warmth, no familiar sound, and yet it is still full of life."
With every meter you descend, something changes. Light weakens, colors disappear in sequence. Red first, then orange, yellow, green. Only blue remains. Then violet. Then nothing. Darkness does not arrive from one direction. It comes from everywhere at once, slowly and completely consuming everything.
Before we descend deeper, look at the smallest life in the upper layer, phytoplankton. Single-celled organisms invisible to the naked eye produce more than 50% of the oxygen in Earth's atmosphere. Not rainforests, not the Amazon. These microscopic drifters, suspended in the top 200 meters of the Atlantic, are what keep you breathing.
This is a bait ball. Millions of herrings gather into a dense sphere and move as if they were a single organism. No leader, no central command. Each fish reacts only to its nearest neighbor, and from millions of simple decisions emerges a collective intelligence powerful enough to deceive sharks and tuna for hours.
Funnus finis, the Atlantic bluefin tuna. 3 meters long, weighing over 600 kilograms, capable of bursts up to 70 kilometers per hour. They are warm-blooded, rare among fish, maintaining a body temperature higher than the surrounding water to maximize muscle performance. Each year they migrate from the Caribbean to Norway and back, tens of thousands of kilometers with no maps, no GPS, guided only by Earth's magnetic field.
Dolphins are not just intelligent, they have names. Each dolphin produces a unique signature whistle, like an acoustic fingerprint, and others in the pod call them by it. They remember companions after years apart. They teach their young hunting techniques through demonstration. The Atlantic is home to minds like these, right at the surface, right before our eyes.
Dermacheles coriacea, the leatherback turtle, the largest living reptile, weighing up to 900 kilograms. They dive deeper than 1,200 meters to hunt jellyfish, prey they pursue across the Atlantic. This species has existed for 100 million years, surviving the extinction that wiped out the dinosaurs. And now, they face the greatest threat in their history, us.
Cyanea capillata, the lion's mane jellyfish, one of the longest animals ever recorded, its tentacles stretching up to 37 meters, longer than a blue whale. No brain, no heart, no blood, a body made of 95% water. And yet, it hunts, reproduces, and has existed for 500 million years, long before fish first appeared on Earth.
The Sargasso Sea is the only sea on Earth without a shoreline, its boundaries defined by 4 surrounding currents. The floating mats of golden sargassum form a complete ecosystem. Hundreds of species cling to it, hide within it, feed upon one another, entirely dependent on this drifting forest. It is also where European eels travel over 6,000 kilometers to spawn, and then die.
200 meters. Sunlight officially ends here. Above is the world you know. Below is a world humanity has only just begun to glimpse. More than 80% of the ocean floor has never been directly observed. What we are about to enter, much of it is being told for the first time. Let's keep descending.
The mesopelagic layer, also known as the twilight zone, stretches from 200 to 1,000 meters. This is a realm of perpetual dusk, where day and night lose their meaning, and light becomes only a faint memory from above. Few people realize this zone holds the largest animal biomass on the planet, more than all surface fish combined, yet we know almost nothing about it.
Myctophody, lanternfish. These tiny fish, only a few centimeters long, may be the most abundant fish on Earth by total biomass. Each night, they rise to the surface to feed. Each morning, they descend into darkness to avoid predators. This vertical journey of hundreds of meters, repeated every 24 hours, is the largest migration on the planet, and almost no one knows it exists.
A siphonophore is not a single organism, but a colony. Thousands of tiny individuals called zooids are linked together. Each evolved to specialize in a single task: hunting, digestion, reproduction, propulsion. None can survive alone. It represents one of the most blurred boundaries between individual and collective in the natural world, and some species grow up to 50 meters long.
Vampiroteuthis infernalis, the vampire squid from hell, a scientific name that lives up to its meaning. Neither true octopus nor true squid, it is the last surviving member of an ancient evolutionary lineage. When threatened, it turns itself inside out like a cloak, exposing sharp spines. and releases not black ink, but clouds of bioluminescent light, turning darkness into illumination.
Humboldt squid communicate by changing the color of their skin. Millions of chromatophores expand and contract in an instant, producing complex flashing signals we have yet to decode. They hunt cooperatively, coordinating attacks without sound, using only light. It is a complete language, written on skin, read by sight, in total darkness.
Regalachus glesnae, the oarfish. Reaching up to 11 meters, it is the longest bony fish on Earth. For centuries, oarfish appearing near shore were believed to signal earthquakes and tsunamis, not entirely without basis, as they inhabit tectonic fault zones. They were never filmed alive in their natural habitat until 2001. Before that, we only knew them from bodies washed ashore.
Marine snow. The remains of phytoplankton, animal waste, mineral shells of microorganisms all clump into tiny particles and fall continuously from the surface. It is the only food supply for life below the light zone. But marine snow is also a carbon pathway, carrying atmospheric CO2 to the ocean floor. The Atlantic is absorbing humanity's carbon and burying it for thousands of years, every second, every day.
Isurus oxyrhynchus, the short-fin mako shark, the fastest shark in the ocean, reaching 70 kilometers per hour and leaping up to 6 meters above the surface. Like the bluefin tuna, makos are warm-blooded, maintaining elevated body temperatures to maximize muscle and brain performance while hunting. They can detect prey movement through electroreceptors across their snouts.
Every night at sunset, an extraordinary event unfolds across the global ocean. Billions of organisms, lanternfish, shrimp, small squid, copepods, rise from the depths to feed at the surface, then descend before dawn. This vertical migration moves vast amounts of carbon from surface waters to the deep ocean each night, one of the most important mechanisms regulating Earth's climate, and we are only beginning to understand it.
Copepods, smaller than a grain of rice, may be the most numerous animals on Earth. Trillions are drifting in the Atlantic right now. They are the central link in the entire marine food web, feeding on phytoplankton, eaten by small fish, and ultimately sustaining whales. If copepods disappeared, the ocean ecosystem would collapse within weeks.
Architeuthis ducks, the giant squid, growing up to 13 meters long with the largest eyes in the animal kingdom, 27 centimeters wide, the size of a dinner plate, designed to capture the faintest photons in the darkness. For centuries, they were legend, the Viking kraken, the sailor's sea monster. Not until 2004 were they first photographed alive in their natural habitat, and much about them remains unknown.
During World War II, the US Navy discovered something strange. Sonar repeatedly misread the ocean floor. They called it the false bottom. Later, scientists realized it was the deep scattering layer, a dense concentration of organisms reflecting sound waves like solid ground. Billions of creatures gathered at the edge of light, forming a biological layer so thick, sonar mistook it for rock. War had accidentally uncovered one of the greatest ecological phenomena of the ocean.
1,000 meters. Sunlight does not exist here. Not a single photon from the sun reaches this layer. Temperature, 4 degrees Celsius. Pressure, 100 atmospheres, 100 times surface pressure. This is the bathypelagic zone, the realm of true darkness, stretching from 1,000 to 4,000 meters, and it holds more mysteries than everything we have discovered above.
Melanocetus johnsoni, the black anglerfish. The female carries a biological lure on her head, its tip filled with bioluminescent bacteria, the only trap she needs. Prey approaches out of curiosity or mistake and disappears into elastic jaws capable of swallowing something twice her size. Her stomach can expand almost endlessly. In this darkness, you never know when the next meal will come.
Male anglerfish are up to 60 times smaller than females. When he encounters a female, he bites into her skin and begins to fuse, circulatory, nervous, and digestive systems gradually connecting before dissolving. Eventually, the male is no longer an independent individual. He becomes an appendage of the female, existing only to provide sperm. This is one of the most extreme forms of biological integration in nature.
Dragonfish possess a weapon no prey here is prepared for: infrared light. Most deep-sea creatures cannot see infrared because evolution never created sensors for something absent from their environment. Dragonfish use it as a stealth flashlight, illuminating prey without the prey knowing it is being lit. They truly see in the darkness, while everything around them remains blind. Macropinna microstoma, the bear eye fish. Its head is completely transparent, like a diving helmet, allowing its tubular eyes to rotate freely inside, looking upward to detect faint backlit prey silhouettes, then rotating forward to strike. We did not know this until 2004, because bringing them to the surface shattered the transparent dome. For decades, we described the species incorrectly. Chaliotis sloani, the viperfish. Fangs so long it cannot close its mouth, curving outward to form an inescapable trap. Along its belly, photophores emit light matching the faint glow from above, allowing it to disappear when viewed from below. In this darkness, even darkness itself becomes a weapon. Grimpeteuthis, the Dumbo octopus, lives between 1,000 and 7,000 meters, the deepest living octopus known. Its body is nearly transparent, lacking an ink sock because concealment is unnecessary where there is no light. They do not follow seasonal reproductive cycles like surface species. Females carry eggs and can lay them year-round when conditions allow. In eternal darkness, time operates differently. Himantolophus, the deep-sea football fish. Its round body is an adaptation, no streamlined scales for speed, because speed does not matter here. Energy conservation does. It barely swims, hovering and waiting. Its lure emits silver light, different from the common blue, attracting prey accustomed to blue glows. In the darkness, even the color of light is strategy. In absolute darkness, some species evolved in the opposite direction. Instead of dark camouflage, they became transparent. There is nothing to see as light passes through like air. This is the most perfect invisibility possible, not by blending into the background, but by erasing one's shadow entirely in a world without light.
Mantis shrimp can strike with acceleration faster than a bullet, 23 meters per second in under 3 milliseconds. The punch creates cavitation bubbles, low-pressure bubbles that collapse at temperatures as hot as the surface of the sun for a fraction of a second. Even if the direct hit misses, the shockwave can kill the prey. They carry a miniature nuclear-level physical weapon in their claws. Deep-sea hatchetfish practice camouflage known as counter-illumination. Their bellies glow through photophores at precisely the same intensity as the faint light from above. Viewed from below, they vanish into the background and cast no shadow. Predators see nothing. It is optical stealth technology, perfect, battery-free, evolved over millions of years. Acanthoster plancy, the crown of thorns starfish. Not a deep-sea species, but a perfect example of how one species can destroy an entire ecosystem. Each individual consumes coral. During outbreaks, they blanket and eliminate entire reefs in months. Ecosystems built over centuries erased in a single season. And outbreaks are becoming more frequent as oceans warm.
Somniosis microphycephalus, the Greenland shark, the longest living vertebrate known on Earth. Radiocarbon analysis of islands tissue suggests one individual lived over 400 years, born before Galileo invented the telescope. They grow so slowly, they reach sexual maturity only at 150 years. In 2 degrees Celsius water, time literally moves slower.
Sperm whales dive to 2,000 meters and can hold their breath for over 90 minutes. In total darkness, they hunt giant squid using echolocation, producing the loudest clicks in the animal kingdom, 230 decibels, powerful enough to stun or kill prey before contact. Many sperm whales bear large circular scars, marks left by giant squid tentacles in battles no human has ever witnessed. Stillness is the most effective hunting strategy in darkness. Many species here never actively chase prey. They wait, day after day, month after month, hovering or lying motionless, consuming minimal energy. When prey comes close enough, in an instant. Where food is scarce and energy more precious than gold, patience is not a virtue, it is survival. 4,000 meters. The seafloor, not rock, but mud. Fine sediment tens of meters thick, accumulated from marine snow over millions of years. This is the abyssal plain.